So the idempotent law says that again, let P be a proposition. Then if we look at the disjunction of P with itself, we will get P. And if we look at the conjunction of P with itself, we'll get P again. Let's take an example, right? So let's say that the statement P says that it rained yesterday, right? Let P be this statement. Then the first statement, right? The first statement over here, this proposition, this compound proposition, P or P. So that would be P disjunction P will be it rained yesterday or it rained yesterday, right? So this means that it rained yesterday or rained yesterday. Either one of these should be true. If you see that if P is true, then P or PP disjunction P is also true, because it is basically saying the same thing and giving us option to choose the true value again and again, right? Also, if you look at the second part of the law, which is the conjunction, this says that it rained yesterday, it rained yesterday, and it rained yesterday. It rained yesterday. So it's basically again saying the same thing, and it is stressing on the same truth again and again, right? So if the statement it rained yesterday was false, then P conjunction P, the second one, would be false, as well as the first one would also have been false, right? So if you find two propositions, if you find the same proposition separated by a conjunction or a disjunction, right? Doesn't matter. If you find a proposition separated by like repetition of the same proposition separated by a conjunction or disjunction, what you can do is that this is a formula. You replace this by the proposition itself. Similarly, if you look at the second one, the second law, let's say again the P be a proposition that let's say there is a coin toss, so the result is heads, right? Let's say this is the proposition. Then we want to see whether the negation of P is P or not. So if P is result of heads, then negation of P will be result is tails, right? Or maybe result is not heads. Then negation of P will be what? Result is heads, right? So if we take the negation of the statement, two times you're taking a negation, then it becomes the same proposition. Okay, so let's move on. Let's look into some other laws. The third law, law 3. So we studied two laws till now, right? Law 3. Law 3 is a little now this is the law where we are bringing in two propositions, right? Two or more propositions we'll bring in. We'll first start with bringing in two propositions over here. So this law is called commutative commutative commutative, right? Commutative law. This law is called the commutative law. So here let P and Q be two propositions. Two propositions. Let P and Q be two propositions. Then again there are two operations, right? We are very much interested in looking out at the two operations. What are the two operations? One is the disjunction, another is the conjunction, right? So P if you take the disjunction of P with Q, that will be equivalent to Q disjunction P. You see what we did? We just reversed the order, right? So Q was the second one. Now Q has become the first one, right? So similarly, even for conjunction, it works. P conjunction Q is equivalent to Q conjunction P. So you'll say, I mean, you might be asking, you might be interested to know where this is being used. We will soon see that. We'll solve a problem and we'll see where this particular law is applied. Right? So we were studying the commutative law. This is a third law. We had studied the idempotent law, where if we take a proposition and look at the disjunction of the proposition with itself, right, it gives us the same proposition. Law 1, part 2 says that if we have a proposition P and we are interested in finding out the conjunction of P with itself, we will get the same proposition. Okay, then we look into the law 2. Law 2 says, law 2 is interesting. It's and very easy to remember and understand. Law 2 says that if there is a proposition and we take the negation of this proposition and we take the negation of that again, so we are taking the negation two times. Now if we take the negation two times, then we will get the same proposition back. We are currently studying the law 3. The law 3 says that if we are having two propositions P and Q, then let's say let's say in the first case that we are finding out what is P disjunction Q. It turns out that the result is going to be same as Q disjunction P, right? And similarly, if we have P conjunction Q, right, the result is going to be Q conjunction P. The order is changed, right? So even if the order is changed, the truth value remains the same. So even if order is changed, truth value remains same. This is what the commutative law states. Let's look into an example very quickly, right? Let's say that again, P be a statement, right? P be a statement that it is raining now. Hmm? And Q be a statement that uh, uh, what? It is hot, correct? So uh, P and P, sorry, P disjunction Q, P or Q would be it is raining now or it is hot, right? Whereas Q disjunction P will mean that it is hot or it is raining now. Okay, so you see that these two statements, right, are essentially the same statements. Both of these, the meanings are the same, right? Hence, P, this statement, so this shows that P disjunction Q is actually equivalent to Q disjunction P. Okay, cool. Now let's look at the other operation. The other operation is P conjunction Q. P conjunction Q means it is raining now or it is hot, right? And Q conjunction P means it is hot or it is raining now. right? So now again you see that these two statements are exactly the same. It's okay, not or, my bad. Okay, so it should be and over here. And 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 now, so now you see that these two statements are again exactly the same. It's just that we are changing the order in which the statements are being written, right? So this says that P conjunction Q is actually equivalent to Q conjunction P. Cool. Can I get some thumbs ups here if you have understood? Okay, thank you so much. All right, all right, amazing. Thank you so much. Great. Let's now move to the next law, right? So the next law is called okay. So before going to the next law, let us have a recall of the three laws. The first law is the idempotent law, which says that if you take a proposition and find the conjunction of the proposition with itself, it will give the same proposition. Disjunction of a proposition with itself is the same proposition. If you take the negation of a proposition two times, right? Double negation, negation of a proposition, you will get the same proposition. And the third law, the most recent law that we learned, is the commutative law, in which if you take two propositions and you take the disjunction of them, the order does not matter at all. Okay, now let's look at law 4. So the law 4 is the distributive law. Distributive law. Okay, so no, I my bad. I should first go with the associative law and then move to the distributive law. That will make more sense. Associative law. So here, let P, Q, and R be propositions. We have more than two propositions, right? So in the first two laws, we had one proposition each. In the second law, we had two proposition. Here we have three proposition, and here is a here we are trying to understand what happens if we have like three propositions. So let's say that there is a proposition P and there is a disjunction here and there is a bracket, right? So there is a bracket here. Inside the bracket we have Q disjunction R. Okay, so basically it is like we are supposed to do the bracket first, right? So BODMAS rule, we all know that bracket has to be done first. So it turns out that this order does not matter at all. I mean, the grouping does not matter at all. You can as well open this bracket and restructure your compound proposition as follows. You can find out P disjunction Q in the beginning, and then you can do the disjunction with R. Okay. Similarly, not only with disjunction but also with conjunction. So P conjunction, if you have like Q conjunction R inside the bracket, then you can dissolve the bracket and associate P with Q under conjunction, and then you can find out the conjunction of the result with R. One very important thing that I would want all of you to remember here is that both of these should be same. Okay, both of these should be same. The operation outside and the operation inside, both of these have to be same. If they're different, we will have a different law, right? Okay, so just in order so that you remember this thing, I'll highlight these particular operations, that these are same, right? Okay. Okay, cool. Now, without without going into an example immediately, I would want to state the law 5, right? So the law 5 is called the distributive law, distributive distributive law. And again, let P comma Q comma R be propositions, propositions. Then again, two things are going to occur. See, I told you a little while back, right, that if the symbols are same, then if the operations are same, we use the associative law. If the operations are different, so let's say there is a disjunction outside the bracket over here, and maybe I'll write that a little closer, right? And inside the bracket, you have a conjunction, right? Inside the bracket, you have a conjunction. So this will be something really amazing. Okay. So here we'll open a bracket. We'll write P disjunction, the first one inside the previous bracket Q. Then inside the bracket in the left hand side, we have a conjunction. So a conjunction will come outside. And then inside the bracket again, we will have P disjunction R, right? So this is very similar to what we do in arithmetic, right? So if we have 5 multiplied by 2 plus, let's say, 4, right? So what do we write that as? We write 5 multiplied by 2 plus 5 multiplied by 4. And that makes sense, because 5 multiplied by, 5 multiplied by 2 plus 4 is 5 multiplied by 6, which is equal to 30. And 5 multiplied by 2 plus 5 multiplied by 4 is actually 10 plus 20, which is equal to 30 again, right? So this is the distributive law. Here, what is the distributive law? Okay, so I will just share this. Okay, anyhow. Mm, anyhow, my bad. Yeah, so what are we doing is that we have got an operation outside and that operation outside is being distributed in two different brackets, right? So you see that we have got the inside operation as a conjunction. The inside operation remains, it comes outside in the middle of the two brackets. Whereas the outside operation, which was the disjunction, it gets distributed into the two brackets, inside the two brackets, right? Okay. Now there is the second distributive law, right? In a very similar way, the second distributive law says the following, right? The second distributive law says as the following: the first distribution law and the second distribution law. The second distribution law says that if we have one proposition and then we have a conjunction, inside the bracket there is, let's say, another maybe another operation which is different from the one outside. So it is a disjunction inside the bracket. Then this will be equivalent to P conjunction Q disjunction P conjunction R, right? So very similar way. It is exactly same as what we had done previously. Outside we have got, on the left hand side, a conjunction. The conjunction gets distributed inside the bracket, right? Whereas the disjunction which was there inside the bracket, right, which was there inside the bracket, comes out of the bracket. Okay, cool. So here again, what is the important thing? The important thing is that the operations inside and outside should be different. The operation inside and outside must be different. That is a rule over here. Okay. And finally, the law 6. We'll study like around three more laws, three to four more, four more laws. Yeah, we'll study four more laws today, right? The law 6. Let's go to the law 6. Okay, the law 6. Okay, so the law 6 is called the De Morgan law. De Morgan's law. This is called the De Morgan's law, right? So here again, we will consider two propositions. Let P, Q be propositions. Propositions. Then, then, uh, okay, yeah. So then, what happens is we will have again two rules over here under this same law, right? First rule is as follows. The first rule is as follows. Let us take the let's say the disjunction of P and Q, and we'll take a negation. See, now as we are going into the further laws, we are increasing the variety of our operations, right? In the beginning, since the beginning, we have been working with the same operation, one operation, right? P disjunction Q, P conjunction Q, both of them are P. The negation of P, right? If we repeat a particular operation on the same proposition, what happens? Then we were in the commutative law. We introduced a third proposition, or maybe four, five, six, how many ever you can add, the rule remains the same. But the operation is the same, right? In the associative law. So here the operation remains the same. In this case, the rule is different. Further, so now in the distributive law, we started to use two different operations, right? The result was different. Now in De Morgan's law, the result is going to be different again. So we have taken two operations. One operation is inside the bracket, one operation is outside the bracket, right? So this will be equivalent to the negation of P disjunction Q. P disjunction Q, negation of that is negation P, okay? Negation P, I am putting this in a bracket for clarity. The disjunction converts itself to a conjunction. Conjunction, negation of Q. The disjunction, if you note very clearly, the disjunction has converted itself to a conjunction, right? And very similarly, you might have guessed it right, if we have a conjunction and take the negation of the conjunction, this will give us negation of P, right? Disjunction, negation of Q. Again, what is happening here? There is a conjunction which is getting changed into a disjunction. So, if we summarize the De Morgan's law, we'll say that negation of disjunction is to equivalent to conjunction conjunction of negations. And similarly, very similarly, what we can say is the following: the negation of conjunctions of conjunction is equivalent to disjunction of negations. Okay, so this law is pretty simple to remember. It's called the De Morgan's law. If there are two propositions P and Q, you take the disjunction and take the negation of the disjunction, it will be equivalent to the conjunction of the negations. And if you take the conjunction and the negation of the conjunction, the point number 2 on your screen, this will give you the disjunction of negations. Okay, I'll pause here for a minute, and I would want to see if you have any questions here. Are there any questions? Can I get some thumbs ups from people? Hmm. Okay. Thank you. Looks good. Okay. Fantastic. Great. So pretty simple topic, right? Cool. Let's now. Yes, Suhas, you have a question? Your hand is raised. I think by mistake you raised your hand. Hmm? Okay. I'm just going to ignore it. I'll come back to it in a while if required. Excuse me. Okay, cool. So having done these six laws till now, we will move quickly to a few more laws which are pretty simple laws, right? This there is a seventh law. So the seventh law is called the identity law. Identity law, right? So this this is again very simple. Okay, the identity law is extremely simple. So let P be a proposition. Proposition. Only one proposition. We'll work with one proposition, and also we'll work with true and false. Right? What I mean to say is that if we have a proposition, okay, if we have a proposition and we kind of, like take the conjunction with true, okay, that will be equivalent to the proposition itself. Let's see what happens. So let's say that we have got P here and T here and P conjunction T. We are constructing the truth table. Okay, let's construct the truth table. So T is always T. P can either be T or false, true or false, right? So true conjunction true will be true. False conjunction true will be false. So you see that we immediately have the P and P conjunction T to be exactly the same, right? Okay. The second one, the other identity law says that if you have a proposition P and you take the disjunction of the proposition with false, okay, you will always get back the proposition P. Again, let's look at it. On the left side of your screen, I'm going to draw the truth table. So P, F, and P disjunction F, right? On the left hand of your screen, you can see that I am drawing the truth table. F is F always, it's always false. So that is the possible truth values. So truth value of P can, the proposition P can either be true or false. Now, true disjunction false, the first row, it is going to give us true, because in disjunction, if at least one of the propositions is true, we'll get a true. Whereas the second one, it is going to be false. So again, even here you can see that the P is exactly same as P disjunction F, right? Okay. So now having said that, right, we'll move on to the next law, right? So the next law says the next law is pretty similar to this law actually. So the next law is called the domination law. Domination, domination law. So there is some domination going on. Domination, right? So there is something which is getting dominated. So this law is as follows. Again, here also we'll be having a single proposition. Let P be a proposition. What is a proposition again, guys? Proposition is a statement which can either be true or false, right? So the domination law states that, again, two things, okay? So the domination law says that if you have a proposition P and you have a disjunction of P with truth, then that is equivalent to truth. Whereas if you have the truth tables of these are pretty simple, I would, like, it's very easy. Okay, and if you have a proposition P and you take the conjunction of the proposition with false, with the false statement, then you will get a false. The truth value of this particular will be false, right? And the truth tables of these are pretty simple. So P and T on the left hand of the screen, I'm doing the truth table for the first one, P conjunction T, right? So the possible values of T are T and T. So there is no difference here. Yes, the P can have, the proposition will have a truth value of true and false. So the first row, right? The first row is P disjunction T. So T truth, disjunction truth is truth. At least one of them should be true. And the second row is false disjunction true is true. Correct? Now you see that here um, the the left hand side of the rule 1 is P disjunction T, which is T and T, whereas the right hand side is T T. Correct? So both of these are exactly the same. The truth values are exactly the same. And on the other hand, on the right hand side, I'm going to write down the truth table for the second law, right? So P and F is there. We need to find out what is P conjunction F, right? So P conjunction F. So F is always F. It's always false. So P, the proposition can be true or it can be false, right? So the truth conjunction with false is always false, and if there are like false statements, the conjunction is false always. And then you can realize that the left hand side of number 2 is false, right? P conjunction F, and the right hand side is again F, right? It's false, always it is false. So the domination law is also valid, right? I hope you have understood that. Okay, so these are the 8 laws that we are going to learn today, and I think that should be enough for today's lesson.